Let's talk about one of the most important figures in quantum mechanics, Wolfgang Pauli. He made several groundbreaking contributions, but his most famous is the Pauli exclusion principle, which plays a key role in explaining the structure of atoms and the behavior of matter. What is Pauli's exclusion principle? In 1925, Pauli came up with a brilliant idea: no two fermions like electrons can exist in the exact same quantum state. In simpler terms, within an atom, no two electrons can have the same set of quantum numbers. These numbers describe things like the electron's orbit and spin. So, even if two electrons are in the same orbit, they must have opposite spins. This principle is super important because it explains why electrons arrange themselves in specific ways around an atom. It's the reason why we have the periodic table and why different elements have different chemical properties. Without the exclusion principle, we wouldn't understand the stability of atoms or how elements bond to form molecules. Why it matters. The Pauli exclusion principle is key to understanding the structure of matter. For example, it explains why certain gases like helium are stable, and why the electrons in atoms don't just collapse into the nucleus. It also helps explain why matter occupies space and doesn't just collapse into a single point. This principle is essential in chemistry, solid-state physics, and much more. Other contributions by Pauli. 1. Advancing the concept of spin. Pauli played a huge role in developing the idea of spin. He showed that electrons have an intrinsic property called spin that can take one of two values. This concept was crucial in refining our understanding of particles and their behavior in atoms. 2. Pauli matrices. In quantum mechanics, Pauli introduced Pauli matrices, which are mathematical tools used to describe spin-12 particles like electrons. These matrices are still used today in many areas of quantum theory. 3. Neutrino hypothesis. 1930. Pauli also made a bold prediction about a new particle called the neutrino. He proposed its existence to explain missing energy in beta decay experiments. The neutrino was eventually discovered and is now a fundamental particle in modern physics. Pauli and quantum mechanics. Pauli's work helped build the foundations of quantum mechanics. His exclusion principle, his contributions to the understanding of spin, and his neutrino hypothesis all played crucial roles in shaping the field. Beyond just electrons, his ideas help explain the behavior of fermions, which make up much of the matter in the universe. Why Pauli is a quantum hero. Wolfgang Pauli is rightly considered one of the heroes of quantum theory. His exclusion principle isn't just a minor detail, it's a fundamental law that helps explain how the entire physical world works, from the tiniest atoms to the biggest stars. His work laid the groundwork for much of modern physics, and his influence reaches far beyond quantum theory itself. That's why Pauli remains a true quantum hero. In short, Pauli's contributions are key to how we understand atoms, electrons, and matter itself, making him one of the giants in the world of quantum mechanics.